Welcome to Chapter 2, questions 94 through 98. Question 94. Find the area of each figure below. Show all work. Remember to include units in your answer. On part A, we have a square. So in a square, all the sides are the same. So to find the area, we can take 7 centimeters times 7 centimeters. And therefore, the area would be 49 centimeters squared. On part B, we have a triangle. So the area is equal to 1/2 base times height. So we have 1/2. The base is 10. And then the height represents the 4. Remember, it should be where the perpendicular lines are, where it forms that right angle that represents the height and the base. So on this one, the area, 1/2 of 10 is 5. 5 times 4 is 20. So the area of the triangle will be 20 inches squared. And then on part C, we have a trapezoid. So we're going to have the area is 1/2 the height times the sum of the bases. So the area is equal to 1/2 times 6 is the height, and then base 1. It's this full, well, it doesn't matter which base it is, 1 or 2, but one of them is that full length, and then the other one's this one. So if I do the longer base, that's going to be 16. And then the shorter base just represents from here to here, which we can see is 8 units, or 8 feet in this case. And so therefore 1/2 of 6 is 3. 16 plus 8 is 24. 24 times 3 is 72. So this would be 72 feet squared. Question 95. Multiply each expression below, then simplify the result if possible. So on part A, we can use the distributive property. 3x times 5x is 15x squared, and then 3x times 7 gives us 21x. And those are not like terms, so they'll stay just as is. On part B, we have a binomial times a binomial. You can use the distributive property, or you can use your generic rectangle. So x times x is x squared. X times 3 is 3x. And then we have 2 times x and 2 times 3. And then you can combine your 3x and your 2x to be 5x. So we got x squared plus 5x plus 6. And just remember, if you want to use your generic rectangle, you can say x plus 2 and x plus 3. So you're still going to get the same 4 terms that I got from above, and then you can combine your 3x and your 2x to be 5x. Part C, same thing, so we can use, I'll just go ahead and use the generic rectangle on this one to start. So this will be 3x plus 5 and x minus 2. So this will give a 3x squared, 5x, negative 6x, and negative 10. So therefore, 3x plus 5 times x minus 2 is equal to 3x squared minus x minus 10. And then on D, this one I'll just use the distributive property. And this is going to give us 2x times 5x, that's 10x squared. 2x times minus 4, negative 4, that's negative 8x. 1 times 5x is plus 5x. And 1 times negative 4 is minus 4. So this simplifies to 10x squared minus 3x minus 4. And so once again, you can use the generic rectangle to help you in terms of multiplying the binomials, or you can use the distributive property. Question 96. Graph the following equations on the same set of axes. Label each line or curve with its equation. Where did the two curves intersect? Well, since I don't have my coordinate plane on here like I should, I'm going to have to kind of sketch one out here, and then we'll do the best we can to get everything lined up the way it needs to be. So with the linear equation, y equals negative x minus 3, since it's linear, let's just go ahead and graph that. The slope would be negative 1 with the y-intercept at 0, negative 3. So here, and then we'll go down 1 over 1. Once again, since I don't have the coordinate plane on here, it's going to be somewhat of a sketch, but try to get a accurate enough graph that we can find where the intersection is. So we want to label this line since we are going to graph another equation. Alright, and then we'll take the second one, y is equal to x squared plus 2x minus 3. And you can use a graphing calculator on this to help you graph it. Since I don't have that available on here, I'm just going to go ahead and create a t-chart and plug in some values so we can see what it looks like. So as you can see, I created the table. Once again, you could get this also from the graphing calculator. A couple things to try to recognize when you're graphing a quadratic equation is that you do see the symmetry that occurs as you should see with the parabola. Alright, so we're going to go ahead and graph these points, -4, 5 approximately. So about right there, -3, 0, which is where one of the intersection points of the line was, -2, -3, -1, -4, 0, -3. There's another intersection. 1, 0, and then 2, 5. And there's the graph for y equals x squared plus 2x minus 3. And we want to make sure we do answer the question. We did graph the following equations on the same set of axes. We labeled the line or the curve with its equation. And then where do the two curves intersect? So let's look. One intersects here at the point 0, -3. And then another one intersects on the x-axis at -3, 0. So those would be our two intersection points. And so make sure you write that down. Don't just label it on the graph. Make sure you answer the question. Question 97. On graph paper, plot quadrilateral ABCD. Given the 4 points, what is the best name for this shape? And we're going to have to justify our conclusion. And then we'll do a couple other things. So I went ahead and set it up. Once again, without my coordinate plane, it's a little bit harder. But it looks like we're going to have one set of parallel lines. And then these other two are formed together. So it looks like we have a trapezoid. But if we want to know maybe a little bit more, could it possibly be an isosceles trapezoid? To know that, we'd have to look at these two distances and figure out if they are the same. And we can kind of set that up by looking at the triangle that's formed here. And so here and here, this distance between 2 and 4 is 2 units, which is the same thing that happens here. And then this would be 1 unit and 1 unit. So those distances would be the same. So not only is this a trapezoid, but it's also an isosceles trapezoid because two sides are parallel and the other two sides have the same length. Alright, on part B, quadrilateral A', B', C', and D' is formed by rotating the original quadrilateral 90 degrees clockwise about the origin. Name the coordinates of the vertices. So you can use your tracing paper to take that trapezoid and rotate it 90 degrees clockwise. So make sure we are going in this direction. And when you do that, your new vertices will be A' will now be at 7, -2. B' will now be at 8, -4. C', 2, -4. And then D' will be at 3, -2. On part C, find the area of ABCD and show all your work. So we need to know the height. Well, we can see the height represents 2 units, and that's going from when we originally had this set up at 2, 7. So this is supposed to be at 2, and then it goes over to 4. So that's a matter of 2 units. So that's the height of the trapezoid. We also need to know the base, and so from A to D, your y-coordinate, A to D, your y-coordinate changes by 4, and then from B to C, your y-coordinate goes from 8 to 2, so that's 6 units. So the area of the trapezoid is 1/2 times the height of 2, and then base 1 plus base 2. So therefore the area would be 1 times 4 plus 6, or 1 times 10, or 10 square units, or units squared. Question 98. What is the probability of drawing each of the following cards from a standard playing deck? Refer to the glossary entry playing cards if you need information about a deck of cards. There's 52 cards in a deck. Face cards, there's 3 in each suit, and there's 4 total suits. So that means if you're going to pick a face card, you're going to pick 12. There's 12 possibilities out of 52 cards, and then you can reduce that to 3 out of 13. On part B, what's the probability of a card printed with an even number? So think about your even numbers: 2, 4, 6, 8, 10. So that's 5 in each suit, and there's 4 suits. So that means there's a total of 20 even numbers out of 52. And then once again, you can reduce that, in this case, by 4. So that would reduce to 5 out of 13. Part C, a red ace. Well, there's only 2 suits that are red, and there's only an ace in each of them. So that means there are 2 possibilities out of 52. And then that will reduce to 1 out of 26. And then part D, a purple card. Well, usually the cards are red and black from a standard deck of cards, so there's no purple card, so that would be 0 possibility out of 52, or just a 0% chance.